So there's two ways that we can prove the Pythagorean theorem. It's not going to be until high school that you're expected to really break down the proof. This year you learn what it is, what it means, how to calculate with it. Using a calculator, you are not expected to do the Pythagorean theorem on pencil paper, right? You can use a calculator. But there's two ways that we can prove it. One of them is using geometry, and one is actually using algebra and proving where that equation, a squared plus b squared equals c squared, comes from. Okay. So an algebraic proof can actually be used by labeling the sides of all these little triangles in here. Okay, so take a look at what we've got. We have one big square, and it's created by these four triangles together in this unique shape. And then when they do combine together, they make this big square in here. So can we write an expression that represents the area? How do I find the area of a triangle? Who remembers how we find the area of a triangle? Helena.
Length times width divided by 2.
So we take the length times the width, and we divide it by 2. Did anyone know of another way, like another way that we can represent that value? Michael?
Base times height times median.
Yeah. The formula that a lot of people see is 1/2 base times height. Now, some of us look at this and think, like, why is somebody using length and width and the other person using base and height? They do represent the same thing. The reason that we take half of it, this triangle is really, if I added the same triangle at a different angle, I'm actually just finding the area of a rectangle. So I can find the area of the rectangle here and then cut it in half. So looking at this triangle here, we have a base of A, a height of B. What is the area of that one? If you told me I'm going to multiply the base times the height, what does that look like here if my base is A and my height is B? Like, what if the base was 2 and the height was 4? Right, okay, so if my base was 2 and my height was 4, it would be 8 because it's 2 times 4. But right now, I don't have 2 and 4. I have A and B. So how could I show that I'm multiplying A and B? Just A times B, yeah. So one of the triangles would be A times B, but then what do I have to do to it?
You got to divide by 2.
Divide by 2. Okay, so I can even show 1/2 times A times B. Okay, so that means this is half AB, this is half AB, this is half AB, and this is half AB. Because they're the same triangle. As you can see, they're little angles. So how many AB do I have if I put all 4 of them together? Well, I have half here, and half here, and half here, and half here. So if I have 4 of them, what am I going to do with this?
Multiply you put it in a bracket.
Multiply by 4, so how many do I have? What would that number be?
2.
2. Good. 2. Good. Okay. What's the area of this big white square in here? How do I find the area of this?
C times C.
C times C. So we could say C squared. Now how about, and this is the last part before we start to put it together, what about this whole square? What's the side length of this square? A plus B. So if I had A plus B and I wanted to find the area of it, what would I have to multiply?
A squared plus B squared. No.
What am I multiplying? I'll show you. A plus B times A plus B. So you're actually not going to see this until high school. Because this is what we call multiplying binomials. So if I multiply this, which you will learn next year, it really is the distributive property just twice. We would multiply A times everything and then B times everything. So what this would become, you were right in the beginning, Michael, A squared plus, it's actually going to be 2AB plus B squared. And you are not expected to know how to do that just yet. You are going to learn that next year. So now let's start to put it together. We already did that. So, if I expanded this, we just did that. So now, we said that the area of all four triangles was 2AB. So this is all four triangles. And I'll just do that. And then we said that C squared was the white square. Is it fair to say that the area of all this green and then this white, is it fair to say that that's the area of this whole thing?
Yes. Yes.
Why?
Because
It makes up the whole thing, right? The only thing that makes up this entire big square are those four green triangles and the white. So we're saying that these have to be equal. And you're right, if you saw that on a picture, like that would make sense. Again, you are not going to be asked to break down the proof, but we do want to go through where it comes from. So now, let me go back. Let's take a look at this equation. What do you notice is similar between the two sides? What's on both sides? Variables. We don't call them letters, but you are right. What else do you see that's the exact same on both sides? 2AB. Do I need them? If they're the same and I had a scale, what would happen if I took them both away? Both sides would still be equal. So imagine I removed it. What are you left with?
Oh, Pythagorean theorem.
So basically what we just proved is that a squared plus b squared has to be equal to c squared. Okay, so that's actually where the equation comes from, the formula. We don't often go through where formulas come from because it does become very complex. I'm not going to ask you to prove the Pythagorean theorem. In high school geometry, you will work with the proof more. In 8th grade, you're not expected. But the idea in 8th grade is that you have an understanding of where the A, the B, and the C come from and why that square makes sense. So I'm going to show you a quick video that breaks down the Pythagorean theorem.